Hello everyone, two particles are projected obliquely from ground with same speed such that their range are same but they attain different maximum height h1 and h2. Then the relation between r h1 h2 is what? So it is given that the two particles have same range and speed is also same, right? So we know that if the speed is same, then for two angle the range can be same if the sum of the angle of projection will be 90 degree. For example, if I write r is equals to u square sine 2 theta by g, so you could see sine 2 theta is equals to sine pi minus 2 theta. So I could also write it as phi, so 2 phi rather. So I will equate the two. Then you can see theta plus phi is equals to pi by 2, right? So it is said in the question the two particles have same range if they are projected with same speed, right? Then here the theta plus phi will be equals to 90 degree, right? So let's talk about the maximum height reached by the particle. So if I talk about the particle 1, so it will be u square sine square theta by 2g, and another particle is projected at an angle phi, so I will write u square sine square phi by 2g. Simple. Now we have to find out the relation between the two, right? So you can write it as u square sine square. So I will write phi is equals to pi by 2 minus theta in division 2d. So it will be equals to u square cos square theta by 2g. So if I will multiply the two, equation 1 and equation 2, after multiplying equation 1 and equation 2, I will get h1 into h2 is equals to u to the power 4 by 4g, right, square sine square theta into cos square theta. Simple. So let's put this value sine theta into cos theta is equals to sine 2 theta by 2, right? So just replace this sine square theta into cos square theta by cos square theta by sine square 2 theta by 4. So let's replace it. So I will write here u square by 4g square into sine square 2 theta by 4. Simple. Now if you compare here, the range was u square sine 2 theta by g, right? So if I want to replace this expression by range, so you could see this is what? U square u to the power 4 it was, right? U to the power 4. So if I take this 1 by 16 outside, right, so then you will be able to see that this is u square sine 2 theta by g whole square. Now you can compare this with this expression, right? This is r square, right? Now if you see the option was in h1 h1 into h2 terms, so that's why I multiplied h1 into h2, right? So what we found, h1 into h2 is equals to r square by 16. So from here I could write r square is equals to 16 into h1 into h2, right? So this will be our answer, and this will be the relation between the particles projected with same speed and having same range and having the maximum height h1 and h2, then this will be the relation between range and their maximum height reached. So you can see B is the correct option. And this was our question. Thank you.
Question is, a particle is projected with speed u at an angle theta with horizontal from ground. If it is at same height from ground at time t1 and t2, then its average velocity in time interval t1 to t2 is. So we can say here this is the path of the, let's say, projectile, and in the question it says at time t1 and t2 the particle is at same height. So here we can say at time t1 and t2 the particle is at same vertical height. This is t1 time, this is t2 time. Hence we need to find the, let's say here, average velocity in time interval, let's say t1 to t2. Hence we can say here average velocity is net displacement by net time. So here, since there is no vertical displacement, therefore the horizontal displacement here in time of, let's say, t1 to t2 can be said as, we know here that this u velocity at an angle theta, hence x direction velocity, let's say, remains same. So the distance covered by this projectile in x direction in this time interval can be said here as s is equal to u cos theta into the time interval, which is equal to t2 minus t1. So this here is equal to, we can say as u cos theta into the time gap here is t2 minus t1, and delta t is the time interval which is equal to t2 minus t1. Now here t2 minus t1 cancels out. So this here average velocity comes as u cos theta. Amongst the four options we can see here, option number 3 is the correct answer. So 3 is our answer.
Hello students, today our question is the position of a projectile launched from the origin at t is equals to 0 is given by s is equals to 40i plus 50j m meter here, and at t is equals to 2 second. This is at 2 second here. If the projectile was launched at the angle theta from the horizontal, then theta is, so we have to find the theta and take g is equals to 10 meter per second square. So we have A, B, C, D option is given here. So we have to find which option is correct. So the solution of this question is, we have the horizontal velocity initial. So this is given to us, ux is equals to 40, and this is at time 2 second. So we get ux is speed equals to 40 divided by 2. So this is 20 meter per second. So we can draw the initial diagram here. So diagram on x and y axis. So in this direction we have uy, and in this direction we have ux, and our u velocities in this direction, and we have the this, and the our graph is something like this, and this is t equals to 0 here. So from this we can write here vertical velocity initially is equals to, so we can write here uy is equals to 50. So this is 50 here, and we know that s is equals to ut plus half at square. This is the equation of motion. So from this we can write here uy. So we have s is given to us. This is, we have to find the uy here. So s is 50. So we have uy into t. T is 2 second here. Time is 2, and we have half, and acceleration due to gravity is minus 10 here, and we have t square is 4 here. So we have initial velocity is equals to 50 is equals to 2 uy, and this is 2 and 2 will cancel out. So we get minus 20 here, and from this we get 2 uy is equals to 70, and now we get velocity in y direction is 70 divided by 2, that is 35 meter per second here. And from this we can write here tan theta is vertically velocity, and this is divided by horizontal velocity. So this is 35 and this is 20 here, and this is 7 by 4. So from this we can write here, this is equals to 20 meter per second, and this is 35 here meter per second here. So this is 35, and here is, this is angle theta here, and from this we can write here theta is angle that is required is tan inverse 7 by 4. So this is our answer here. Now we check which option is correct here. So our option C is correct. Thank you.